Hi, I am Saurabh. This video is the technical walkthrough of Extenflow's architecture and how it operates LLM and agent systems in production. This is not a demo, it's for engineers who want to understand execution control, failure handling, and auditability under the hood. Most agent failures in production are not about prompts or model quality. They show up as execution failures, retries that repeat side effects, partial failures mid-workflow, permissions that differ per step, and the inability to explain what happened after an incident. These failures often look fine externally. The system produces plausible output while doing the wrong thing underneath. API gateways can authenticate and rate limit, but they don't understand AI execution. They can't enforce rules like block API is detected or require approval before a high risk action. Action flow exists because these failures happen inside execution paths, not at the API boundary. Action flow is not an agent framework and not a prompt abstraction. It sits between your application and the systems agents interact with models, tools, data sources, and external APIs. Its job is not to decide what to do. Its job is to decide whether execution is allowed to proceed. Exonflow supports two execution models, gateway mode and proxy mode. Gateway mode is where most teams start because most teams already have AI code in production. If you're already using LangChain, LangGraph, Crew AI, or custom orchestration logic, Gateway mode lets you keep that stake unchanged. Your application first calls Extenflow for a policy pre-check. We evaluate system policies such as PII detection, SQL injection scanning, and rate limits. If the request is approved, Extenflow returns a context ID. You then run your existing agent or orchestration code exactly as it is today. After you receive the response, you call Extenflow again to audit the result. 3 calls, no setup rewrite, governance added around the execution. Your orchestrator still plans and executes. Extenflow decides whether execution is allowed and records what happened. Proxy mode is different. In proxy mode, Extenflow becomes the execution runtime. Your application sends requests directly to Extenflow, and Extenflow handles policy enforcement, model routing, cost controls, multi-step execution, human approval gates, retries, and audit logging. This is the recommended model if you are building a new system or want end-to-end governance without managing orchestration yourself. If you are integrating into an existing system, use gateway mode. If you are building from scratch, use proxy mode. One important difference between the two is audit depth, which I will come back to later. At a high level, Extenflow consists of two core services. Your application connects to agent on port 8080. This is the entry point into the system. The agent evaluates system-level policies before any execution occurs. This includes things like PII detection, SQL injection scanning, and rate limits. These are fast, rule-based checks and typically add only single-digit millisecond overhead. The orchestrator running on port 8081 handles more dynamic concerns. This includes LLM routing across providers, tenant or org level policy evaluation, such as PII reduction and cost controls, multi-agent workflows, as well as approvals, retries, and execution gating. Both system policies and tenant policies can be configured independently, including separate controls for LLM access and MCP servers. Postgres is used to store policies, audit logs, and execution metadata. Redis handles caching and rate limiting. Each component has a narrow, clearly defined responsibility. This separation is intentional and critical for reliability. An interesting consequence of this architecture shows up once teams start using it in practice. One thing we consistently see is that teams usually begin by placing Extenflow in front of a single workflow or agent to evaluate policy enforcement, auditability, and execution control. As usage grows, running some AI workflows through Extenflow and others outside it tends to create fragmented audit logs, inconsistent policies, and duplicated observability. For this reason, teams that continue using Actionflow often standardize on it as a single control plane for AI workflows, while keeping their existing orchestration frameworks and execution logic unchanged. Policy evaluation always happens before any model or tool call. If a policy blocks execution, the request stops immediately. There is no partial execution and no cleanup required. System policies run in the agent, tenant-specific policies run in the orchestrator, and usually trigger in proxy mode. The same evaluation model applies to MCP server calls. Policies are enforced before these tools access databases, APIs, or external systems, and responses are scanned before being returned to agents. System policies are compiled once and cached in memory. Tenant-specific policies are cached with background refresh. This design allows Actionflow to enforce governance in line without introducing latency bottlenecks. Actionflow supports multi-step workflows, but not as a general-purpose orchestration framework. There are two distinct models depending on who runs the workflow. In multi-agent planning mode, Actionflow can execute workflows directly using its native planning system. Plans can be derived from natural language or defined using agent configurations. Actionflow generates the execution steps, runs them, and governs every transition. Workflows can be sequential, parallel, or conditional, and retries can be configured. Each step is evaluated against configured policies, and the decision trail is maintained. A safe first step does not guarantee that later steps are safe. If you already use LangChain, LangGraph, or QAI for multi-agent planning, Actionflow does not replace them. Instead, Actionflow provides a workflow control plane. Your external orchestrator still plans and executes the workflow. Before each step, it calls Actionflow for a governance decision. Actionflow evaluates policies and returns, allow, block, or require approval. The orchestrator proceeds only if execution is allowed. This way, you get a decision trail and governance while keeping your multi-agent orchestration intact. Important clarification. Actionflow supports orchestration only where governance requires presence at the execution time. We are not competing with LangChain, LangGraph, or QAI on planning sophistication. These tools focus on how work is planned. Actionflow focuses on whether execution is allowed. For high-risk actions, Actionflow supports human approval gates. This is an enterprise-only capability. Execution pauses before a side effect occurs. Approval is requested. The decision and justification are recorded. This makes side effects explicit and intentional, rather than implicit and accidental. Actionflow is designed to make AI execution explainable after the fact. You can see what ran, what data was accessed, which MCP server was queried, what LLM provider was invoked, what policies fired, and why execution was allowed or blocked. Actionflow supports EU AI Act Article 12 record keeping out of the box. Compliance report export is enterprise only, as it requires immutable retention and regulatory artifacts. The actual depth of audit data depends on how Actionflow is integrated. In gateway mode, Actionflow provides per call audit logging. This includes policy decisions, provider and model, token uses and cost, in-temper detection hashes for integrity verification. This is sufficient for usage tracking and baseline compliance when execution happens outside Actionflow. When using the workflow control plan, Actionflow adds workflow level audit data. Each step decision is recorded, including approvals and policy matches, while execution still happens in your external orchestrator. In proxy mode, Actionflow provides a complete deterministic execution overview. This includes full decision chain on top of earlier gateway mode details, step-by-step execution, retries and transitions, approval events, redactions, and full user and tenant attributions. If you need regulatory-grade traceability across multi-step workflows, proxy mode provides that out of the box. This difference in audit depth is intentional. It reflects how much execution context Flow controls. Everything I have shown so far is supported by a broader capability surface, integrations with 10 plus orchestration frameworks, MCP connectors for databases, a full policy system, audit logging and compliance tooling. I won't go into each of these here, but they are all built on the same execution and governance primitives we just saw. Policy evaluation is designed to be fast enough for inline enforcement. Static checks typically complete in single digit milliseconds. Gateway pre-checks usually add around 10 to 15 milliseconds end to end. Flow runs locally with Docker and deploys cleanly on Kubernetes. There is no hosted dependency. All policy evaluation, execution control, and audit logging runs entirely inside your infrastructure. For development and rollout, Flow is designed to be exercised like a real system. You can run it locally, write integration tests, simulate policy failures, and load test governance paths before production. We include guidance for local development and testing so teams can validate behavior under stress, not just happy paths. This matters because governance systems shouldn't be trusted blindly. They should be testable, observable, and predictable before they sit in the execution path. Flow is not trying to replace Zen frameworks. It is the control plane that makes them operable in production. If you are building systems that touch real users or real data, this is the layer that prevents silent failures. Clone the repo, run Docker Compose up, and try it locally. Documentation is at docs.getactionflow.com. If you have technical questions, open a GitHub issue or send a private email at hello@getactionflow.com. We treat those as engineering discussions, not sales conversations. Thanks for watching.